In section 9.4, you're going to learn about arithmetic series. So to start, a series is, by definition, an indicated sum of terms in a sequence. So now I'm going to take that pattern or list of numbers and I'm going to add them together. There's two different types of series, finite and infinite. Finite means that it's countable or it definitively ends. So if you want to compare it to a TV show, Breaking Bad. Main character had terminal cancer. It was definitely going to end at some point. It only ran for 5 seasons. An infinite series, on the other hand, is something that could go on for forever. So comparatively, you could think of a storyline like Grey's Anatomy, where that's been running for like 20 seasons, and they could just keep going forever and ever and ever. There's no terminating or definitive storyline in there. So if I want to find the sum of an arithmetic series, instead of counting every single term together, especially when you get to like a really long list or sequence, I'm going to use this formula instead. Sn, so that's capital S with the subscript n, that tells us I'm finding the sum of the sequence, equals n over 2 times a1 plus an. So this formula is actually kind of easy to work with. Once you know what to plug in, you're good to go. A1 represents the first term in the sequence. So the first number that you see in that list is your A1. On the other end, AN is the last term of the sequence, and they'll always give you that as well. Finally, N represents the number of terms, so how many numbers or the quantity of numbers in that sequence. So in our first example, let's find the sum of an arithmetic series. What is the sum of even integers from 2 to 100? So again, I could count 2 plus 4 plus 6 plus 8 and go all the way to 100, but if I use that formula that was just given to you, it's going to take me a lot quicker to do that. So using this formula, I'm starting at 2, I'm going all the way up to 100. For n, I just want to think logically, how many even numbers are there from 2 to 100? There's 50, so my n value is 50. So now, instead of counting from 2 to 100, I'm just going to plug this formula in, plug this into my calculator, and I get 25 times 102, which is 2,550. I can also use the Greek letter sigma to indicate a sum. So even though this looks really fancy and really complicated, we're just going to focus on how you read these and then work with it from there. This is something, especially if you're going to take pre-calc, you want to be familiar with. For example, let's say I have the sequence 3 squared to 4 squared to 5 squared all the way to 108 squared. I could rewrite this in sigma notation as this. So let's break down what all these parts mean. N equals 3 represents our lower limit. Keep in mind that I'm starting with n equals 3. My first term is 3 squared, which is 9. You'll see that in a later example where it's kind of important to distinguish those. Next, my upper limit is 108. So that's what's going to go on the top there. And finally, looking at that, I can see, okay, it looks like I'm taking those numbers and squaring them every time. So my explicit formula or my rule is going to be n squared. So my rule will always go like in the sigma. And then looking at sigma notation to find the number of terms, what I'll do is I'll take the upper limit minus my lower limit plus 1. So in this example, 108 minus 3 plus 1 gives me 106. So reading that, I could see, okay, I have 106 terms. So next, let's find the sum of a series given sigma notation. So I want to find the sum of, it looks like my explicit rule is 5n plus 3. I'm starting with my first term and going all the way up to 70. So using my formula, here I need to plug in for a1, an, and n. What's important to note here is that for a1, I'm not going to plug in 1. To find my a1 value, I'm going to plug 1 in for my n and figure out what a1 is. So 5 times 1 plus 3 gives me 8. So that's my A1 term. For AN, on the other end, I'm going to pick my upper limit. So I'm going to plug in 70 here. So I'm going to do 5 times 70 plus 3, which gives me 353. Finally, easiest step, if I want to find N, I'm going to take my upper limit minus my lower limit plus 1, which gives me 70. Plugging all this stuff in, I'm going to get 12,635.